All right, we're going to move on to some simplifying of square roots today. You guys are going to be so impressed with yourselves after you learn this lesson. I haven't even taught this to the honors classes yet, so you have a one-up on them. You can ask them what the square root of 8 looks like simplified, and you'll be able to do it, and they won't. So here we go, simplifying square roots. Let's show you what I mean. All right, we're going to simplify these if it's even possible. All right, here's how we're going to simplify square roots. We're going to do the prime factorization of the number that's inside the radical symbol there. That's what that's called, a radicand. Okay, so 20 is divisible by 2, which is 10, and 10 is divisible by 2, that's 5. So the prime factorization of 20 is 2 times 2 times 5. Now, we've done that before. Okay, so we can write the square root of 20 as the square root of 2 times 2 times 5. Now, here's what we do to simplify this. We can think of that as the square root of 2 times 2 times the square root of 5. All right, what's the square root of 2 times 2? That's 2. So basically, this is the square root of 4, which is 2, and the square root of 5, that's an irrational number that we're not going to do anything with. So we have simplified the square root of 20. We've made it 2 times the square root of 5. Let's do this process a couple more times. I know that's probably a lot for you real quick. But basically, we're going to take 24 and we're going to write it as prime factorization. It's divisible by 2, and then 2 again, and then 2 again, and we end up with 3, which is the prime number. So the prime factorization of 24 is 2 times 2 times 2 times 3. So what we do at this point is we look for pairs. Okay, we have a pair of 2's. We have one pair of 2's. So I'm going to look at this as the square root of 2 times 2 times the square root of 2 times 3. Because I know that the square root of 2 times 2 is 2. The square root of 2 times 3, I can't do anything with. There's no pairs in there. So that's the square root of 6. So there. To simplify the square root of 24, we would make that 2 times the square root of 6. You can check that on your calculator too. The square root of 24 is equal to 2 times the square root of 6 if you put them both in decimal form. All right, one more, the square root of 27. Okay, let's write it in prime factorization first. It's divisible by 3, which is 9. Divisible by 3, which is 3. So the square root of 27 is the square root of 3 times 3 times 3. So there's one pair of 3's in there. So we'll kind of separate those out. The other one we can't do anything with. So what we have here is 3 times the square root of 3. And that's this number simplified. Hopefully you're seeing the pattern here, but I want to do a few more. Just show you lots of examples and see how these are all very, very similar. All right, square root of 30. Let's break 30 up into prime factorization. It's divisible by 2, and then it's divisible by 3, and then we get 5. So it's equal to the square root of 2 times 3 times 5. Now, do we see any pairs here? I don't. Okay, square root of 30 cannot be simplified. It already is simplified. Maybe you want to say it that way. So because there's no pairs of numbers, then we're just going to leave it as the square root of 30, or just say it cannot be simplified. Now 125 can be. So let's write the prime factorization of 125. It's 5 times 5 times 5. We got a pair of 5's that we can group together, and we got that other 5. So simplified, it would be 5 times the square root of 5. Let me reiterate. The square root of 5 times 5, or the square root of 25, is 5. The square root of just 5 is the square root of 5. That's an irrational number that we're not going to be able to simplify. So the square root of 125 is equal to 5 times the square root of 5. And one more here. Square root of 48. We're going to do the prime factorization of 48. It's divisible by 2. Divisible by 2 again. Divisible by 2 again. And divisible by 2 again. We end up with a prime number. So here we go. The square root of 48 is the same thing as the square root of 2 times 2 times 2 times 2 times 3. Now in this case, there's two pairs of 2's. And we've got that 3. Okay? So This is actually a 2, and a square root of 3. And 2 times 2 is 4. Okay, so the first square root of 2 times 2 or the square root of 4 is 2. The square root of 2 times 2 or the square root of 4 is 2. And the square root of 3 is the square root of 3. And we'll just simplify that. 2 times 2 is 4. So the square root of 48 is equal to 4 times the square root of 3. This is called simplifying radicals. And we got some more here, and let's look for some shortcuts. Square root of 50. How about we make that the square root of 25 times 2? So I'm going to show you these a little bit different here. I know that 50 is divisible by 25, and I also know that 25 is a perfect square. The square root of 25 is 5. There, I'm done. Okay, so this number that's inside the radical, this 2, cannot be divisible by any perfect squares, and it's not. It's not divisible by 4 or 9 or 16 or 25 or 36, so I know I'm done. Okay, what about the square root of 90? Okay, well, I know 90 is divisible by 9. Okay, and the reason I'm saying it's divisible by 9 is because I know that 9 is a perfect square. The square root of 9 is 3. So 3 times the square root of 10, and we are done. Okay, and again, you got to look at this 10. Is 10 divisible by a perfect square? Is it divisible by 4? Is it divisible by 9? Is it divisible by 16 or 25 or 36? Those are all perfect squares. No, it's not. So I know that this is simplified. Okay. Ooh, okay, what about 1,000? Is 1,000 divisible by a perfect square? Think of a perfect square that 1,000 is divisible by. It's divisible by 4, but how about bigger? How about 100? Okay, isn't 100 times 10 1,000? So the square root of 100 times the square root of 10 is the square root of 1,000. Now the reason I picked 100 is because the square root of 100 is 10. So there, we've simplified it. Now all three of these could be done using the same methods that I use for A, B, C, D, E, and F. But it would take a lot longer. So look for perfect squares that these numbers are divisible by, like 25, 9, and 100, and work it. And also the number that's inside the radical can't be divisible by a perfect square. Otherwise, you haven't simplified it all the way. Okay, and last thing with these, using the following table, calculate to the nearest tenth the values of the square roots of G, H, and I. Okay. Well, G was 5 times the square root of 2. And this table tells us that the square root of 2 is 1.41. So we can just do 5 times 1.41, and it's about 7.1. H was 3 times the square root of 10. You know what, this would show up a lot better if I was showing it on a dual screen. There we go. So the table tells me that the square root of 10 is 3.16. So I'll do 3 times 3.16, and that's 9.5. And lastly, I was 10 times the square root of 10. So again, the table shows me the square root of 10 is 3.16. So I'll do 10 times 3.16, and that's 31.6. And you know, if you use a calculator and do the square root of 50, you'll get 7.1 about. If you use a calculator and you do the square root of 90, you'll get 9.5. And if you use a calculator and you do the square root of 1,000, you'll get 31.6. You know, just working them backwards. What's 7 squared? 49. That's almost 50. What's 10 squared? That's 100. That's about 90. And what's 32 times 32? Well, that's a little bit tougher, but I'm telling you, it's about 1,000. Okay, so there's simplifying radicals. Maybe a lot to digest today, but you can always rewatch the video, and you can always come in early with questions, or just bring your questions to class. We've got plenty of time. All right, I'll see you then.